Tilt-up and precast construction methods are fast and economical, but like any construction method using heavy elements, are hazardous if not done exactly right. No construction job's so important that it's worth dying for, but people have died on Australian tilt-up sites. Because of concerns about safety, the state government now requires everyone involved in tilt-up and precast work to undergo compulsory training. There's also a new code of practice which complements existing Australian standards and building code requirements for tilt-up and precast work. Safe construction depends on you adhering to proven methods, standards and equipment right from the design stage through to the end of the project. But first, there are some universal points about managing hazards that you should know about. Firstly, you should identify the hazards. Some are easy to spot, but others aren't. You've got to think about the ways people might get hurt or killed during a particular task. Then assess the risks. Ask yourself, what could happen if? Think about how likely it is that that particular thing will actually happen. And remember, the more often people are exposed to a hazard, the greater the risk. Control the risks. You can do this several ways: by eliminating the hazard, engineering a new way of doing the task, keeping people away, or looking at safe behaviour processes like training people, using signs, or increasing supervision. Personal protective equipment is important, but not as critical as the others. Control implementation and monitoring. Having done the first three steps, you must make someone responsible for making sure the safety changes are made and monitored on an ongoing basis. There are multiple hazards when working with concrete panels, resulting in higher risk levels. That's why this video stresses two themes. Communication between people and teams at all stages of the process is vital. And refer to the code of practice and always follow the engineer's instructions. Accidents never happen at the design and engineering stages, but the seed of an accident can certainly be planted there. Communication can counter this.
And then what we're going to end up with is, if we either do an offset panel joint and then do 9-metre wide panels, what weight of panels we're ending up with.
Project and panel design engineers must meet their clients' needs, but remember, people have to actually put up the building safely.
We don't want to design a panel that we know can work in service if they can't lift it or manufacture it. So we regularly will consult with the erection engineer to see if we're doing the things that will be easy on site and safe on site to install.
Engineers must minimise risks by thinking about panel sizes, shapes, materials, the likely sequence of erection, and even whether concrete panel construction is the best way to go on a job. It might not be.
Look, we have a pretty regimented set of guidelines that we use, and we very rarely go away from that because we're comfortable that what we're doing works on site. So the developer may have some ideas that he'll throw forward for different fixings, particularly at the floor location, and if we're not happy, we basically will say no. So we're typically using a pour strip in the ground to tie our panels together, where some developers would like to use angles and fix the panel that way. So we'll go through all those design details to make sure that they're happy with what we're doing, because if they're not, then we generally will walk away from the project.
A major hazard is progressive collapse, where one part of the structure fails, causing other sections to fail too. That means project engineers, site supervisors and the erection team must work together to ensure adequate stabilisation at all stages of construction, especially if a building's overall stability relies on steel wall and roof components. Before pouring, formwork should be carefully measured and checked against panel shop drawings. Workers and their supervisors should be familiar with the requirements of the type of formwork they're using and any issues associated with that method. Reinforcing, Tie-ins and inserts on every panel should be carefully checked by the site supervisor or panel engineer.
This one's approved to continue with.
Bond breakers should be the type specified for the job, with the operator wearing protective gear and others keeping clear. Concrete batches must also be to spec and vibrated well, especially around lifting points and panel corners, then allowed to cure long enough to gain maximum strength. Exactly the same principles apply for precast panels manufactured off-site and stored until needed. At the erection stage, relevant shop drawings and work plans must be on-site so they can be quickly accessed for checking. If it's a tilt-up project, the site supervisor should make sure panels are poured not just in the right sequence, but also where they won't get in the way of lifting. An engineer okayed this panel to be moved more than once. Generally not a good practice, and one that could have been avoided if the builder had got the concreters, erector and crane company to meet earlier on.
Sometimes the beds aren't set up as what you would like them because some panels are bigger, some are smaller. So most concreters will actually set the beds up, biggest on the bottom, working up to the smallest. Now, you try and do your best you can with the concrete companies and say, look, I want this one on the bottom, this one on the top. But still, they will do it their way.
Such situations promote bad habits. Workers have lent panels against other panels without first consulting an engineer. This is an extremely dangerous practice. During erection, the paperwork will include a plan to manage traffic, a job safety analysis, the proposed work method, sequence of erection, and any engineer's sign-offs.
Here I have different scenarios for different types of panels. And we have to work on one of them because all the panels are different.
Yeah.
So if they've got an 8-point lift, this is the scenario that we will try and use. If we go outside of any of these scenarios, I have to get it in writing from an engineer to state that it's fine.
Right.
For example, if I wanted to do a 4-point lift without using a spreader, I would ask an engineer if I can use 6-meter chains coming down onto our sheaves, which he will okay, and if he okays it, then we're right to go. I also have all their certificates for any slings and any shackles and any beams. It's all certified and checked.
When panels routinely weigh 20 or 30 tons, cranes must be suitable for the job and everything well maintained and in good working order. Crane positions need to be planned, giving consideration to stability, other site works, proximity to any power lines, and the potential for the crane to come into contact with columns, braces, or other structures. The rigging system must be as specified for the particular task. Sling lengths are critical, and lifting clutches should be frequently checked for wear or other problems. Team planning right before a lift is critical. The risk of injury rises because panels can be affected by wind. Lifting inserts can fail for several reasons, as can cranes or rigging. For these reasons, anyone not involved in actual erection should be outside an exclusion zone. Those inside the zone must never position themselves or part of their body under a panel, including the final stages when panels are manoeuvred onto footings. Any risk to passing pedestrians or vehicles must be actively managed. Bracing is a key failure area. That's why they must be fixed exactly according to the shop drawings. Generally, there are at least 2 at 90 degrees to the panel. If strong backs are needed to support panels with doors or other cutouts, they'll be specified on the shop drawings. Any modifications to rigging, hardware, the erection sequence or bracing must first be approved in writing by the appropriate engineer. In fact, tilt-up's a construction method where you can't make any decisions yourself. You need the engineer's approval. Once fixed, brace anchors should be tensioned, and if the engineer's drawings specify certain anchor bolts, braces or other hardware, that's exactly what must be used. Most importantly, the site supervisor, riggers, engineer, crane driver and builder need to be in constant communication so they all know how the job is meant to proceed. The crane must never be released until all braces are fixed. Once all panels are up, braces should be quality checked, then checked again every few days for any signs of movement or loose fittings. They mustn't be removed without the approval of the engineer. When a tilt-up or precast project's finished, builders and contractors should review what went well and what didn't. Most teams review as they go, but don't at the end of the job. It's a critical part of making sure hazards are removed and bad practices are identified and dealt with before someone is injured or killed. Again, communication is the key.
Look, tilt-up is a fantastic form of construction. And it's a safe form of construction done properly. It's efficient because it's quick. You're putting up big spaces of building and big areas under roof in short time frames. But obviously we're dealing with large structural elements, so it needs consideration given to the safety aspects. And the seminars I went to were highlighting that there should be a process that everybody is involved.
Learning quickly from mistakes saves lives, and that life could well be your own.